We have drawn a one-point perspective object, like this, just a cube. Let's draw a space, like a room, that this object could live inside of. It's the same procedure. We have drawn an object We've drawn a one-point perspective object, a cube. Let's expand this and we'll draw a one-point perspective room. Same procedure as an object. This object is behind the picture plane. We're going to draw the room behind the picture plane. It's going to be like this. We have our viewer, our station point, and here's the distance between the viewer and the picture plane, and the room that we're drawing is behind the picture plane. So this viewer is not inside the room. It is the viewer's outside the room. They are like an audience member in a play. And here is the fourth wall. We have to remove the fourth wall to be able to see inside the room. But the procedure is exactly the same as when we drew this cube. I'm just going to make up the dimensions of the room. Here's my diagram. Here are my units. We'll make the viewer. We'll make this distance. Let's make it 1, 2, 3, 4. Make it 5. Just a little bit outside the cone of vision. So the viewer's 5 units from the left wall, and we'll make them 4 units from the right wall. Here's 5 and 1, 2, 3, 4 units from the left wall. Lines that go back in space go to the center of vision. And to measure the depth of it, well, let's make the room, we'll make it 8 units deep. So I'm going to make this a 0. I'm going to measure this line. You could just as easily do this one. Here's a measuring point. This is another measuring point. So I'll make this 0, and then 1, 2, 3, 4, 5, 6, 7, 8. So this room, it is 9 units wide. The viewer's 5 units from the left wall, 4 units from the right wall, and let's make the room 7 units deep. So I'm making this one my 0. I can make this my 0. It doesn't matter which line you measure. You find out which line you want to measure, and that becomes your 0, and you count over. I'm going to count over 7. 1, 2, 3, 4, 5, 6. There's 7. I could count over 7 to the right side too. If I count over 7 to the right side, then I have to use the measuring point on the left. If I count over 7 to the left, I have to use the measuring point on the right. Here's 7, measuring point, and that becomes, there's 7 from here to here. So if I went to the other side, 1, 2, 3, 4, 5, 6, oh, one more, 7, 1, 2, 3, 4, 5, 6, 7, go 7, and then go to the other measuring point, you see you get the exact same answer. You always stop on the line that you start counting from. Like if I stopped there and made that the back of the room would be 1, 2, would be 3. And if we made the height of the room, we'll make it, let's try 8. I'm using 1/2 inches as my increments. There's 2, 4, 6, 8. And then it is just connecting dots. Vertical lines straight up and down. Lines that go back in space go to the center vision. Now this last line, if I make a horizontal line, this point and that point, they should line up with each other. And if they don't, that means that something is wrong. And that thing that's probably wrong is that one or more of these lines are not straight. Maybe the vertical lines aren't straight, or the lines that go back to the center vision, they're not done very carefully. The horizontal lines might not be straight across. So you have to be careful using your tools to make sure that you don't get a little sloppy and have the line, the tools not like all tight and snug. Now, if we wanted to bring the room forward, kind of like this drawing, so the room comes out in front of the picture plane, the procedure is not that different from this one. You can draw things on the back side of the picture plane or the front side of the picture plane. Let's just make it come out maybe 3 units out in front. So we'll make this distance 3. This, of course, is not to scale. So lines coming out in front of the picture plane come in this direction. And if I wanted to measure 3, this is the line I'm measuring. Let's do this one. This is the line I'm measuring, and I want to make this 3. So this is my 0. I count over 1, 2, 3. And then come forward. There's 3. If I wanted to use this one and count over to the left, I can go 1, 2, 3. And then, see, I have to use this measuring point. See, it is exactly the same answer. I could have done this line, it could have done that line. It doesn't matter which line you do. Then, again, I am back to connecting dots. Horizontal lines straight across. Vertical lines straight up and down. This is going off of my paper. It's going a little bit outside this cone of vision. That's not too far outside the cone of vision though. See this surface here. All of this right at the measuring line. This surface is touching the picture plane. That's right here, this surface. One more. Let's put the person inside the room, because here the person's still not inside the room. They're outside of the room. If we want the person to be inside the room that they are drawing, it's going to surround the figure. It's going to go behind their back. A new diagram. This one's getting a little messy. Okay, we'll do the same room. We'll make it 4 units to the right. 1, 2, 3. There's 4. And 5 to the left. 1, 2, 3, 4, 5. And these lines will come forward. This is the back of the wall. See, if we make the height of the room, let's make it a little different so it won't be off of my paper. Here's 2, 4, 6. We'll go 6. Again, each ½ inch on my ruler is 1 unit. So there's the back wall here, and then here's the room coming surrounding the station point, the viewer. Now the viewer is, let's figure it out. The viewer is 8. The viewer's 8 units from the picture plane. That's this distance. This is 8. So from here, where the viewer is standing to this picture plane, that's 8 units. And you can see the room goes beyond that. So the problem with putting that in my drawing, well, one of the things is going to be way outside the cone of vision. Everything's going to be like super distorted. And when you're drawing something, you're projecting the object to the picture plane. If you had something straight across from the viewer, 90 degrees from where the viewer's looking, you cannot project that to the picture plane from the viewer's eye. It has to be in front of where the viewer's standing. If you projected something here right across from the viewer, it would extend out parallel to the picture plane. It would never hit the picture plane. So the viewer, we said, was 8. 8 units from the picture plane. If I made it 8, let's measure this line. So this will be my 0, this one. 1, 2, 3, 4, 5, 6, 7. There's 8. And I'm going to extend this out. And here's 8. Extend that out. It's never going to hit that line. See, they are parallel with each other. This is also a very good trick to make parallel lines. See, if I extend that out, Not only is it not really practical because it's way outside the cone of vision. You're never going to draw things inside the cone of vision if you're inside of this object. These two lines are running parallel with each other. They never meet. See the picture plane and this line parallel with each other. So 8 from here to here never hits the picture plane. You cannot draw this dot on your piece of paper. You have to be inside of that just a little bit. And still, it's going to be really far away. I mean, you would have to have a huge piece of paper to find something like that on this picture plane. And here's my cone of vision. So, putting the viewer inside the room, it's possible to do. It's not hard to put them inside the room, but it's not practical to draw things that are surrounding the viewer, that are outside the cone of vision. It's going to be very distorted. The only way to put the viewer inside of a room and draw inside the room, draw things that are right next to the viewer, to the left and right of the viewer, is if you enter the world of 4-point perspective, or 5-point perspective, or 6-point perspective, where the picture plane is no longer flat, but it is curved.